So hello everyone. So my name is Kris Verlaenen. I'm a jBPM project lead and a principal architect for the business automation suites. And so I guess today we're mostly going to talk about, the process side, right? So we all know business automation is kind of a mix of lots of different technologies, and I guess day three is about process. And I guess they asked me to kind of give an update from the trenches. And I guess, so maybe the first question is, why are we talking about trenches? Like, is there a battle going on? And I guess, so in the presentation today, maybe that is, maybe explain a little bit, maybe from our side, as in like from the engineering team and building this project and product associated with the community, etc. From our point of view, what are we worried about? What are we doing? And what are we focused on? And what might be relevant for you as well? So first of all, I guess, trenches, and I guess, is there a battle going on? And I would argue, so I've been in the project for almost 15 years now, I guess. And so it's amazing on basically how expectation from customers of what you're able to do or what they're expecting from the software that we're writing. It's kind of like it's always increasing. I remember like a decade ago, everyone was talking about a workflow engine that was kind of like a state machine, and that's what they needed. That's what they embedded inside their applications, and that's what they ran with. Funny thing is that workflow actually is kind of the new term again. Seems to be becoming more popular than some of the other terminologies like process automation again. So it's kind of a round circle. But over the years, what people are expecting that you help them with, it has increased tremendously, right? So, we all know, I don't have to explain the need for automation in general, right? So we all know automation is just, it's necessary. We need to eliminate overhead. We need to, eliminate human manual tasks if they're not necessary, etc. Do as much as automation as possible. But also, what you need to automate also just becomes more and more complex. You need more capabilities. You need to kind of involve other people in that end-to-end cycle as well. And so, if you look at like the battle that we're kind of constantly doing is to kind of just keep building on our foundation. Like, we build a workflow engine. We've then, and that was already like all of like the early steps are like a decade ago. We adopted the BPM standard as a language shared by lots of vendors that actually non-technical people can use and understand as well. We've integrated all these our technologies, like we've heard about constraints and rules in the past few days. That's all integrated with rules into one offering where you can seamlessly combine these, and then lots of tooling, etc., came next. So people weren't just expecting technology; they were basically expecting technology that will help them not just execute processes, but manage them, create them, make them, share the results, create dashboards, etc. And even then, it didn't stop, right? So kind of capabilities that people were expecting from a process and automation platform is like, well, I just want to create my processes and then just deploy them. I want you to take care of the rest. So I want a service where I can deploy these things to and can just update them, and I want you to take care of that. And then I think was it mostly like 2-3 years ago, there was a big focus on, I just don't want to do these simple processes that are just basically just after this, do that, etc. No, we have lots of complex use cases. We've got knowledge workers that actually know what they're doing. We want to assist them. We don't want to tell them what to do. No, we want to give them the right assistance. So case management on how to address this kind of flexibility, etc., became important. And then finally, I guess like cloud native is now also at the top of our priority list. So because people aren't running this in their own private data centers anymore. They want to be able to, deploy these things in a hybrid cloud. I'm not saying everyone's moving everything into a public cloud, but it's like hybrid clouds and, being able to scale out if necessary, if your own infrastructure is insufficient, or if you quickly want to get something up and running. That's why we're looking at the cloud as well. So this is kind of like a huge evolution, and I think it also is a good explanation of what the value is for developers out there. These are all capabilities we just kept adding to the product, and these are all things that you can optionally leverage. You don't have to use all of these things, but there's lots of things out there that optionally you can use if they make sense, and you don't have to do yourself. So, like I said, I think that all these capabilities are also, to a large degree, why we believe you should consider process automation if you're doing any kind of automation. There's lots of ways to do this. If you're a developer, we know you can write applications that do lots of things automated as well, or there's other technologies that can help with that. Specifically, process automation, I guess, is really meant to help developers in this automation, in this building these applications. So like I said, there's lots and lots of capabilities that we've implemented over the years that you can just pick up and use, whether it's advanced constructs or how to model certain flexible situations, etc. Through reusable building blocks, or if you're looking at first, writing one process is easy, but then you update it and you need to migrate running instances to others, etc. These are all building blocks that are available when you're picking up process automation. A lot of this is, these are, probably valid for process automation in general. So I guess any product out there, some of these benefits are maybe like where we believe we're kind of different from our competitors in what we try to do there. And so, but process automation, it's fair to say that there's a certain amount of learning curve, but once you kind of you're beyond that, you have you have the framework set up, then it's really a great capability to have developers be productive from the get-go and to kind of basically develop applications very quickly, because you can delegate a lot of the automation to the platform itself, but at the same time focus on specifying the logic that you want as part of your process. So it's all about building blocks that you can use and making developers then very productive in doing these things. The other is, it's all about cost saving as well, because we all can write actually. It's very funny. One of the challenges with process automation is everyone knows they can write a simple state machine, and process automation in its most simplistic form is basically just a state machine. But the challenge is really everything that you have to build around it and the scalability. So, for example, writing a simple state machine is easy. Writing some like a scalable platform with distributed timers that can run hundreds of thousands of requests a day, it really is something different. So that's where I guess these platforms, we spend a lot of time on scalability and performance to make sure that whenever you delegate your business logic to us, we will be able to execute that at scale. And then finally, I think process automation is also a huge technology enabler. What I mean by that is that we've got lots of customers that are using process automation and then integrating that with other systems. So, the reality is process automation doesn't solve everything. You still have to write applications. You still have to hook them up with other services out there. But the advantage is that lots of our customers, they're maybe just doing something that other customers have already done, and that therefore maybe we've built into the product, or maybe some of our customers are more experimental. They start experimenting with how can I, let's say, for example, a few years ago, how can I start doing like machine learning and AI? How can I integrate that with my processes to really make them work well together? Well, and then we work with customers on trying to figure out, okay, what's the best way to start integrating these things? And we make that after a while, we learn from that, and we make that kind of knowledge available to other customers. So process automation isn't then just about, the process engine itself, but also it handles lots of information. It knows a lot about your business if you're executing your processes there, and therefore it can be a good foundation as well to do other things on top. Like let's say, integration. We integrate well with, let's say, the Fuse product for integrating with anything out there, or whether it's event driven, or if you're now looking at serverless, for example. If you're now looking at how do I do serverless, well, we're looking into that, And so whenever you're ready, you could start looking into that as well. Maybe, I mean, I would argue at this point, lots of our customers aren't necessarily leveraging that. But by, I mean, using a process automation platform like ours, then I guess we're trying to solve these issues before for you, so that whenever you're ready, you can start leveraging them. And I guess like the other side of the battle, I guess like when I was talking about trenches, the other side of the battle, I guess from our point of view is also typically, I mean, customers really know what they want and they kind of, I mean, they're very strict on what they want. So basically they want us to be, I mean, an open source community. I mean, everything we do is 100% open source. They want us to reinvent ourselves continuously and experiment with the latest and greatest out there because they want to start taking advantage of that. At the same time, or whatever they're already running in production, they want it to be as stable as possible. I mean, it's battle tested, so it's like nothing can go wrong, and they want us to focus on them, on their use cases, helping them as much as possible. That's also a trade. I mean, it's often a difficult trade-off. I mean, and there's lots of other trade-offs, whether we're, I mean, talking about trade-offs between helping the developers build these applications, or I mean, are we, I mean, helping business analysts to be part of the process. I mean, lots of these trade-offs are like a constant struggle where we have to figure out, like, well, I mean, typically the answer, then if you ask the question, if you ask the customer, is like, we want you to do everything, right? And we try, but it's kind of a constant battle. I guess, so like I said, I've been doing this for over a decade, and it's been a long journey. And I guess so the rest of the presentation, I'll basically just try to focus on maybe like, I mean, what we've done in the last 2 years, maybe to kind of explain where we are and how we're moving forward, to kind of, yeah, maybe explain how that could be relevant to developers out there. So I guess in the next month, we'll basically be releasing 7.11, so version 7.11 of the RHPAM. So it's our 7th major release, where we're doing the 11th minor release as part of that release cycle. I think 7.0 was probably 3 years ago or something like that. There's typically a 3 months release cycle that we follow. So if you look at that, so the 7th stream that we currently have is what we call a very stable stream, right? So I mean, we're actively developing it, we're putting new features into it, etc. But at the same time, the core is a very stable core that lots of our customers are relying on. So I mean, basically the engines that are in there, etc. Whenever we're adding features, people basically just expect everything to be as stable as it ever was. So the only thing that it can do is it can only improve. I mean, we've got lots of regression testing, etc. that we're ongoing, but most importantly, there is also backwards compatibility. Our customers don't want anything to change if they've written the application. They want just to be able to consume and keep consuming, while at the same time we do help them with, I mean, making sure there's no CVEs and bug fixing and enhancements, etc. But it's that part is a very stable core that we kind of keep evolving and offering to our customers. And that exists. I mean, so like I said, 100% open source exists in the community as well. What happens in the community even more is that we continuously keep innovating as well. Like, for example, case management is something we started innovating with ages ago, years and years ago, before it actually became relevant. We experimented with case management, actually put quite advanced features into the core engine at that point. And then it took a few years actually before this kind of requirement became actually relevant to a wider customer audience. But then we started hardening these features even more, and then making them part of the stable core of the product. And if you look at what we're currently doing, there's lots of innovation that we're doing with, and I'll go into a few of those, just mention a few, but there's lots of innovation that we're doing there, which lots of it ends up in the stable core, and some of it maybe just ends up being experiments in the community that we kind of collaborate with people on, and some of those things maybe never make it into product because they may be not what we're expecting or what people were looking for. But that kind of struggle is kind of a continuous way of making sure our existing customers keep happy with the stable core, but we keep. And the funny thing is, like, usually the customer wants the stable core, but they want the innovation as well. It just depends on who you're talking to. People that start embarking a new project, they want all the newest and greatest stuff, but they want to have the stable core for anything that they already have running as well, obviously. And so I'll do a few highlights of some of the things that we've worked through in the past year, and I guess maybe share some of the insights and where we see customers kind of moving towards at this point. So I think that's, if we look at what customers are doing, it's amazing how they often, I mean, we seem to be moving, I mean, a lot of them in the same direction. So one of the things we're seeing now is that it seems to be a lot more interest in event-driven processing. So I'll go a bit into that, and straight-through processes. They're somewhat linked. I'll explain a bit about the process editor, because the process, I mean, it's a graphical visualization, right? So it's very important in the whole value proposition of process automation, which is, it's a visible diagram, and you can do a lot with it. And so I guess we've really evolved the process editor to be available everywhere, and that's, I'll give a few examples of why that could be very relevant. We see people, I mean, BPMN has been a standard for like ages, but nowadays it seems like there's more interest in maybe other languages out there. I mean, do we have to use BPMN? I'll explain a bit as well. And then, I mean, we do lots of customers RFPs as well, but I guess we also have I mean, strategically, and I put it kind of like a separate bullet, because it really is like its own strategic goal. I mean, cloud native is like, we've done a lot to make sure that we're evolving everything we do, from core engines to tooling, etc., to really run at scale in the cloud. So I mean, so that whenever you're ready to kind of consume this kind of technology in a hybrid cloud, we'll be ready for you as well. All right. So first highlight, I guess, event-driven, and I guess the reason is that what seems to be happening is kind of basically just combining processes with the microservices approach, right? So, and I mean, it's probably driven by cloud, where I guess these kinds of approaches are more common than before. Is that it's used, if you look at from a stability point of view, or from I mean, how software is developed, etc., being able to split up a big, large software application into lots of smaller applications definitely makes sense. And the same could be true for your processes as well. So where I would argue that traditionally we saw customers huge processes, right? So they were doing end-to-end process development. They were designing their processes, and could be hundreds and hundreds of tasks within one process, or I mean, obviously you can split up processes in multiple processes by using sub-processes, etc. But it was basically like a set of processes and combination with rules, etc., kind of describing the end-to-end behavior. That is very useful if you really want to see the end-to-end interaction that is happening. But it also brings challenges, right? Because every time something changes, you kind of have to change the process, and everything's typically tightly coupled. I mean, you're invoking one service, you're invoking the next, etc., and that one process is basically defining how you should go basically end to end. If we look at the event-driven approach, these processes are basically just split up in much smaller processes, where rather than I mean, directly invoking each other, they just specify the logic for a much smaller part of your application. So you're rather than specifying all your business logic at once, you say like, okay, I'm going to just focus on how to do one part of my problem. And then if that happens, that's just going to generate an event, which is probably going to be picked up somewhere else, but I'm not going to worry about that. I'm just going to worry about, I mean, doing my part, raising the event at the end, and then I'll make sure that, I mean, I know that event's going to be processed at some point, but I'm not going to worry about that in one big process. So we've seen events, I mean, the interest in events grow significantly. First from, I mean, audit events. Obviously, when you're executing processes, there's lots of information that's flowing through us, and we're auditing all of that, so that's easily available. But we saw customers saying like, well, can we get access to those audit events, etc.? So for integration, whether it's like, I mean, so event emitters towards other systems, so we can have access to that event, those events as well, whether that's Kafka or whether that's Elasticsearch or whatever other technology you have. But I guess more recently, I mean, a lot more towards just as part of the processes as well. So basically, processes are decoupled. So you're executing tasks. If something happens, rather than specifying directly what will happen, you're raising events that could be handled, that are then being handled elsewhere, to really start decoupling these things. And then standards like cloud events. I mean, if you're familiar, you have standards for specifying data within in those events. So it's easy to then say like, okay, this is a standardized format to specify the data that I want to send out, so that it's easy for others to consume this kind of information. Kafka is very popular there, and I'll later as well as part of the demo, where this kind of how you easily can leverage, for example, Kafka, but other technologies as well, to kind of then hook all these things back up together. The other thing is like straight-through processing, kind of linked to cloud and to event-driven as well, is that they seem to be more important as well. And I'll define straight-through process because it's not like a terminology that widely agreed that that's typically what it means. So for us, straight-through processes, we define it as processes that you start them and then you run through them in one go. So obviously that means that these are not like processes which, I mean, involve humans, because I mean you can't then you actually have to wait for humans to respond, etc. But they are like straight through. Typically means that they're fully automated. You run through them in one go. And yes, I mean that you still have to take it into account that there could be failures, etc. But the point is that when you start it, you will run through the process in a certain amount of time, which isn't going to take days. And then at the end, you have the results. And the use cases we have, lots of it is things like service orchestration or batch processing, or like I said, event processing. If you have lots of small processes, then I mean, creating events, then that small process is something that you can just run through directly. So a typical example is service orchestration. You've got lots of services out there. You want to combine them by, for example, first, I mean, you're basically typically like querying REST services for information, collecting that all together, and in the end, you do something. Like I said, for example, you create another event that's going to be processed elsewhere, or you store some data somewhere after you've processed this. The advantage of straight-through processes is that we kind of, when we know what you're doing, we can actually optimize a lot these kind of straight-through processes by just making them very lightweight to execute, because we know you're just going to run through them from start to finish. So that made them actually very popular because once we've if we optimize for those, the execution itself is extremely lightweight. And so you can do a lot of these in parallel, and it's a slightly different strategy that you have. So rather than making sure that at every point in the process, you're saving your state so that you can continue if something goes wrong, the approach is much more like, no, I'm just going to run through this. If something goes wrong, I'll just retry. I'll just run through the process again. It's fairly instantaneous, but it gives you really, it's an option to kind of give you cloud scale performance and scalability without necessarily having to kind of like process, store state every step of the way, because basically the use case allows you to. All right, then next, I guess, embeddable process. So I guess, as I mentioned, the process itself is extremely important. It's the language that the developers use to encode the logic, and that people use to to maybe then share that logic with others, sometimes less technical users as well. And so we've made sure that the editor that we have, it's a pure client-side editor, meaning that it's an HTML editor that has no backend. It does not require any backend, so it can be embedded anywhere. And we've got a bunch of examples, but and I'll show you the VS Code. So the first one, I guess the VS Code is this one. So we've embedded it in VS Code, and the VS Code is an ecosystem. So it's not just like your local VS Code that you might have, but VS Code, I mean, that means other technologies that are kind of leveraging the same plugins, etc., whether it's Eclipse Shea or Code-Ready Workspaces or GitHub Workspaces, etc. These are, I mean, they're all sharing the same technology. So that means we make our editor available in your IDE that you're using. It's part of your development cycle. But we make it available actually basically anywhere we might need it. So we've got a GitHub plugin. If you've committed your process to GitHub, with the plugin, I mean, it's all XML based BPMN 2. You can just basically have the plugin render that inside GitHub. We've got an online editor, which I'll show in a second as well. Just go to bpmn.new, and you've got a fully client side. So there's no backend. You're not sharing any data with, with Red Hat or whatever. It's just a client, a web client where you can start drawing your diagrams. We also have like something you can install in your desktop, or what you can embed in your own applications. If you want to show the process in your applications, possibly annotated with additional information, we have embeddable process editors as well. One thing that we've always also seen, and I mentioned that earlier, is that nowadays we see new workflow technology. Like I said, workflow seems to be a new term there that it seems to be picking up again, as in a terminology that's being used nowadays. We see other languages being used. If you look at, especially in the context of clouds, people are looking for various ways of defining workflow, and that's kind of always been the case. And so, like, we've always had, for example, like a Fluent API. It's a Java-based API where you can create processes in Java. You don't have to, you have to, a graphical editor, you can generate these. And these are typically popular in cases when you're like auto-generating processes or something like that. They're fairly popular as well. One of the recent efforts we started or we're collaborating in is the serverless workflow specification. So it's a specification that we're working with other vendors in as part of the CNCF to define a much more JSON or YAML-based specification where you specify your workflows much more like this. So you're specifying the states that you have in your workflow, the properties that it has, and then you basically can hand over that serverless workflow file to your serverless platform, and it can execute that. So that's an alternative that's based on the exact same engine that's going to be executing that. The advantage is that it's a different way that people can use to specify their workflows. If you're more into this, and we see that, for example, Kubernetes developers that aren't maybe specific, aren't Java developers, and maybe they use other technologies. They typically seem to like that kind of representation. So if you haven't seen it and you're interested, definitely take a look at the serverless workflow spec as well. And then, like I said, for RFEs, we work a lot with key customers on when they're implementing it, on figuring out what else we could do to help them, from search capabilities to tagging process variables, immutable Spring Boot deployments, that for people that were deploying our engine as part of a Spring Boot application into the cloud, and they wanted it to be 100% immutable, to Dash Builder, improving the reporting and et cetera you can have on the data that we're collecting with like heat maps, et cetera. These are just a few examples of how we've typically worked with customers on RFEs to enhance these. We typically roll them out in the next product release and make them available to basically, not just one customer. We then make them available to all customers that can benefit from that. And then finally, cloud native. So that's a whole new story. I'm not going to go too much into detail today. So that's what we call our Kogito ecosystem. So we've been looking at our core engines, so Drupal, jBPM, OptaPlanner. We've been looking at how can we really run them at scale in cloud. What else do we need to do to really make them cloud native solutions? So these are like the next gen version of Drupal, jBPM, and OptaPlanner, where we've spent lots of time on refactoring some of the code base to really make it fit well into that ecosystem, but at the same time leveraging the latest cloud technologies as well, things like Quarkus or Service Mesh or serverless, to kind of leveraging these technologies, integrating well with that, all targeting Kubernetes or OpenShift as the runtime to kind of run these things in production. Lots of things that we've been doing. The services you build are what we call the domain-specific services. So you just give us the process, we will generate a very cloud-native service that's highly distributed and integrates well with lots of other services out there. I'll give a quick demo of some of that as well in a second. So basically, what our focus, even though what we do is kind of, feels like it's drastically changing every few years, our goal has always been the same. We're really just offering building blocks for you to build your we call it intelligent applications. It's like to build applications where you want to specify your business logic and as process, or I mean, if you look at the product as a whole, a combination of processes, rules, constraints, etc. You focus on the business logic. You can delegate lots of the concerns to the underlying engines, etc. So you focus here. You focus on business logic. You focus on building your own app, etc. And those apps can just delegate, and you can pick which blocks you need. You can just delegate to those blocks whenever you need. All right, I'm gonna now switch to a demo, and I was wondering, it's like, well, there's so much. I mean, what can I demo? And I guess the challenge is I can't demo everything. And I was like, well, can I? So I took on the challenge to demo a little bit of everything. So maybe if you noticed the demo, that there were a bunch of stars in the presentation that occasionally showed up. I put them here together. For every time the star came up, I'm going to try and touch on it in my demo. So what I'm going to demo is a straight-through process in VS Code. It's going to show you the developer productivity that we have there. And I'm going to use the cloud-native Kogito-based solution that we have. But I mean, lots of these things are possible using other, I mean, the more traditional components that we have as well. And I'll show you a bit like the scalability that we have and kind of the event-driven that we talked about as well. All right, so I'll switch to demo mode. Just confirming, Jeremy, you guys seeing my IDE at the moment?
Yep.
Or anyone else?
Yep.
Yeah, all right.
You're good.
So, all right, cool. So the first, I guess, what I'm showing is I'm showing the VS Code IDE. So I guess this is a Red Hat developers event. So I'm mostly going to show on a bit of around the develop experience, etc. that we have. Like I said, there's others. I mean, I can probably just quickly show. So this is basically the online editor. So if you go to bpm.new, you can, I mean, create your own process, or I just basically just opened the same process as I have here locally. It's a pure web-based environment that I mean, easy to use for anyone. Doesn't even have, I mean, you don't have to be a developer. But for developers that are building applications and kind of extending, I mean, the service that you're building in the IDE, so I'm creating basically a small Quarkus project. So I'm building a small service. The use case that I have in mind is I'm going to imagine as a company, you want to give prizes away and you want people to just try. And if they're lucky, they win a prize. And if not, then that's it. So I got a small service. It's a prize service that all it does is it kind of just determines whether you win a prize by luck, pure luck, randomizer. At this point, there's like a 1 in 10 chance that you can be a winner. If you're not a winner, then too bad. That's where it ends. If you're a winner, we'll look up your information and we'll create the prize. We'll figure out what you've won. So this kind of process is what I would call it's a straight-through process. So basically, you start a process and you will immediately know whether you're a winner or not. And that's it. It's a fairly small process. But it's invoking a number of services. So basically, this is a service, a service that maybe you've written specifically for this application, or maybe you already have something like this. So this is the service that I'm currently running here. It's a separate service that's available through REST. And then there's another service that, I mean, you probably already have in your company, which gets you details about the customers you have based on their username, for example. And then finally, I mean, once you've decided that you have a prize, you will want to, gift the prize, etc. So those are like lots of existing services you might have that you just want to combine in a specific way to solve this problem. So if I run basically this service, so I just created this process. It's not too advanced, and I can just from the command line I can basically just run the service. What it does is it creates a service. So all you have to do is you specify the process, and what we will do is we will turn that process into a service. So if I go, and one of the ways of showing the service, just going to refresh this here, is that the service that we generate exposes itself through a domain-specific API. In this case, it's a REST service that's available, and so it allows me to kind of try and win a prize. And how do I do that? Well, it's just a simple REST post that I have to give some information. And if you're familiar with Swagger, I guess it's just an easy UI to see what kind of endpoints are available to your service and even try them out. So I'm just gonna, I know it's small, so I mean, there's not too much to see. Let me increase it a little bit. All right, so I'm just going to do a post to this REST endpoint. I'm just going to give it my username. I'm just going to execute it and just see whether I won. And if you look here at the response, it's basically returning that I didn't win anything. I think I'm unlucky. I don't accept that. So let me just try that a few times. Yep, I won. All right, so I've tried about it 10 times, and luckily I became a winner. But I mean, this isn't like really giving me lots of information because I don't know what I won or whatever. So that's not very useful. I basically just made a mistake. If you look at the process, I mean, this is what we're creating. If I look at the data that's flowing through this, there's basically a few variables here. The entry is what we start with. We determine whether you're a winner, and then there's the prize. This is the end result. I basically made a mistake because I kind of made it internal, which means that it's not an input, it's an output. It's just something internal to the process. I do want to return that as an out. If I want to return it as an output, that's going to be much more useful for the user itself. So let me just switch that, turn it into an output. The advantage of, so I'm running Quarkus now in dev mode. The advantage of doing that is that if I just save this and I now re-trigger these endpoints, what Quarkus is basically doing, and I show you that here in the console, is it detecting this change and it's hot reloading this change. And you can immediately see that now there's a prize. But since I didn't win one, there's no actual prize. But if I try a few times again, and this is really just a matter of being lucky, you can actually then see that without actually having to restart anything, this is developer productivity, right? So you just made you made a mistake, you change your process, you save it, and there you go. You just immediately see that the change. We make this now available as the output. Your process is returning this kind of information. All right, so I'm not sure if I'm the only one that if that's like if you see a prize competition, you're like, well, can I cheat this? Can I just do this quickly so I always win? So I have two web pages here. One is the score. So you can see that it's just counting how many prizes I've already given out. So it's just two, the two that you already saw. And this is just like I can easily try this, right? I'll just keep hammering this. As you can see, I mean, that's going to be easy. I could win tons and tons of prizes this way. Let me make it a little bit more difficult. Right? So let me just go to the score service. I'm just going to make it not a 1 in 10 chance, but let's say a 1 in 1,000. I'm just going to save this. And again, this is hot reload. It's just reloaded my service. At this point, there's not a 1 in 10 chance of winning. There's just a 1 in 1,000 chance of winning. All right, and then so, like I said, if it's a straight-through process, we know that we can actually process these requests quite efficiently. And so what I'm going to do now is basically, I got a JMeter here, which is just going to generate some loads. So basically what it's going to do, it's going to use 10 different threads and 1,000 requests on each of the threads to try and win a prize. I'm not going to click through this. If there's a 1 in 1,000 chance, then I don't want to do this manually anymore. So I can basically just run this at scale. And so basically this is gonna try and do this. This is gonna be small again. As you can see, and this is all running locally here on my laptop. So this is basically doing a REST call to the service. That service is doing a REST call to another service, potentially yet another service afterwards, etc., to see if you can win the prize. And I'm doing the screen share as well, which is taking a bunch of my CPU. But the throughput of this, basically, that it's like a few thousandths a second. If I'm not doing the screen share, typically I end up about 4,000 requests a second. So, and that's because it's a very lightweight straight-through process. There's not much that I mean, there's no state persistence in between, etc. So I can really run this at scale. So if you can imagine, like I just ran thousands and thousands of these, and yeah, so the prizes, I'll do this again. So that we have we have 8 prizes. I can just run these again. Hang on, I need to clear the data. start a new. So I can see 3,000, about 3,000, and you can see the scores. Well, 36. So it's a lot less. Obviously, it's a 1 in 1,000 chance, but I just hammered through 20,000, well, 30,000 actually in total in the last minute through this service. All right, and then finally, going back to the service, well, this is just returning me the price. It's actually not shipping me any price. And that's why I said with event-driven processes, well, obviously I still want to ship the price. And to show you, I'm basically using a Kafka instance from Red Hat managed services. So if you missed the news a few weeks ago at Summit, we've announced a managed Kafka offering, and this is a trial version that anyone, so if you're interested, anyone can go and you can get a free Kafka instance for 2 days. So I created one, I call it Kogito demo. There's basically one topic in it, which is a shipping topic, and I can use this one for that purposes to try out. So how do I do this? Well, I pre-configured, and so in the application properties, I pre-configured some configuration to make sure that I can actually access this. So let me just quickly re-enable that. But for this process, all I have to do is basically I enable this as a shipping event. I have to do 2 things. I have to specify which type of message it is, and I'm going to make it shipping because that's going to match my. It's going to match my topic. I mean, you can configure this if it's not the same, but you could. And then the other thing I want to do is I want to pass the data as part of the message, obviously, as well. I'm just going to say the message is going to be the price, which is basically this model that I have. All right, that should do it. I'm going to save this again. All right, and now let me just restart my service. No, I actually forgot. One of the things I did want to show, I'm going to run out of time, is this is like a normal Quarkus dev mode. If you're looking at extremely quick startup times, one of the things you could do is you can run this in native mode. So you can actually do a native compile of the service, which will end up making the service start up even quicker. And I wanted to show, I'll skip that, but if you do that, it's basically going to start up in milliseconds, let's say 10 to 20 milliseconds. I can show you, but if you then start the service, the compile step itself takes a while, could be from 30 seconds to a few minutes, depending on what you have. But it's then ideal to, for example, deploy in a serverless environment where you can just take the service down if it's not necessary, and it spins up almost instantaneously if once you need it. All right, so going back to my process, I'm just gonna refresh the screen then and try a few times. Oh, hang on, I need to change back to 1 in 10 chance, otherwise it's going to be lots of clicking that I have to do just to be able to win the prize. So back to a 1 in 10 chance, and let's keep trying, and we have a winner. Oh, I forgot, I need to enable obviously a listener on the Kafka instance as well, which is what I was planning to do on this side. Need to keep trying. And then you can see, so basically at the end, I didn't have to do a lot. Just specify the message, specify the data that needs to send. I hooked it up to the Kafka instance that the managed Kafka test instance that I have. I hooked up a listener here, and you can see as soon as I win, this is notified. Next step obviously is I need to write a process that is just going to listen for this event. It's going to take it and it's going to do the actual shipping. That's the event-driven process. Decouple it, take a process. The next process is basically just going to be one that has a message start event. It's going to hook up to the same Kafka and it's going to execute there. All right, that's what I had to show. I kind of hoped, go back to the slides, just make sure that I mentioned most. So I showed the straight-through processing and the scalability of these, the event-driven process, developer productivity, and in the cloud native. Yeah, I think I did what I wanted to do.
Okay, all right, thanks for that. Yeah, we have several questions. the first question, Kris, I wanted to ask was one of the attendees asked was, how would you draw a line that separates straight through processes using the process engine? Separates the straight through processes using the process engine from straight through processes with an integration platform or framework like Camel, right? What makes one approach better or more suitable than the other?
Yeah, so I guess it's fair to say that different technologies can be used to solve similar use cases. So but I would argue that the approach that we're following here is I guess, different. And I guess, yes, so you can use integration technology to try and build a pipeline like this as well. But the focus that we have is really on doing it in a way that one is like it's like the graphical formats and making sure that you can kind of share this logic with others, and that it actually integrates with the bigger story, right? So whether it's, I mean, from then later figuring out what's actually happening or managing this or like, I mean, redeploying this, or, and that's the nice part, is like you don't have to have all your processes straight through or not. You can have one way of doing things. You specify your logic, and if it's a straight through process, we can just execute it much quicker. So to be fair, I guess the technology in that way, so one of the things we're trying to do is we're trying to work actually with other teams to try and identify, if you use a process as a way to define the business logic, and we analyze and we know what you're doing, what's the best way of doing this? And actually, we're looking with the Camel K team around, well, maybe we can delegate some of that to Camel K. If that makes most sense, we will do that. So this is more like, I mean, this is the experience we want to offer you, like use a business process to define the logic, and then the technology that is necessary to execute this is what we're trying to solve for you. So yes, I mean, there is different, sometimes there's difference, but we try to, I mean, integrate with other products out there to try and make sure that, we'll pick the right technology for what eventually what you're doing. The advantage, we can analyze this and we can therefore delegate some of that to others.
Yeah, I'd like to add too, one of the things that I think really separates like using a process engine from just something we would write in code is if, the organizations we work for employ a lot of people with, MBAs to make decisions about how processes should work, right? And if they want to gather metrics and have a visual representation of that and in collaborative, relationship with the dev teams, then using the process engine makes a lot of sense, right? Because things that are buried in code are buried in code, right? It's not as easy to expose those. It's certainly not as easy to like get metrics around them to get numbers or to be able to make them as fluid and changeable, right?
Yeah, I mean, like I said, I mean, the process itself is typically key in the story, and I guess this, like being able to share this with someone else who's trying to figure out what your price service is doing, it's like, well, this is what it's doing, or you can annotate this and you can show your end user like, well, I didn't show any of the monitoring, but you can annotate this and you can say like, well, this is the path you took. I mean, we've got focus on explainability, where you can explain why you're in the current situation. Why didn't you win? It's like, well, this is why we asked that service, it said no. Or you can, I mean, obviously in this example, this is kind of like all the features around it is to give a certain experience that kind of goes end to end.
Yep. Yeah, and there are a whole other like suite of tools that we don't focus on that do things like analyze your BPMN to see if it meets Six Sigma requirements, right? I mean, so having this documented in a format that you can then apply in other spaces has a lot of value. And then let's see, we had another question about straight through processes. Is this straight through demo process persistent? And if not, what about retries in case of a failure?
Yeah, so a straight through process it's not persisting its state continuously. So it can handle errors, right? So let's say you're trying to invoke a service and it fails, it can retry, right? But it's not. But if something goes wrong that we can't recover from, right? Let's say the service you're invoking is down for hours, right? It's not going to try and say like, okay, let me just wait here and then in an hour try again. What it actually does is it's just going to say like, we failed. So it's going to, the idea of the straight through process is it's going to return you saying we couldn't. I mean, it's going to give you an explanation what went wrong. Or it might just say like, it might then create an event that's going to trigger an admin to go and look at something. but it's not going to keep waiting. The retry for a straight through process is, let's say after an hour, an admin comes in and says that, oh, the admin comes in, he fixes the issue. He's like, okay, I fixed this. He can basically maybe say like, okay, I mean, this is done. Replay messages that all those messages that have accumulated, or the service is back up and running. If you ran into issues, just try again and you'll be able to see. So it's a different way of doing things. It's not really relying on persistence continuously, and it comes with different kinds of consistency promises and guarantees, but that might be fine. I mean, it's fine if all you're doing is, I don't know, get the current temperature, look it up. I mean, look up your current location, get the current temperature, etc. We don't have to stay. I mean, in an hour later, you can just retry. You're at a different location. That's fine. So it's a different kind of use case. It doesn't work for everything, right? It's not, and so because it's not using persistence in the same way as a high consistent environment is, it actually gives obviously a completely different kind of scalability as well.
Somebody asked if the demo was running on top of OpenShift, which you answered by saying it's on your laptop. But what would be the difference in running it on OpenShift?
Right. So I'm running this locally, and I'm actually not running. I'm not running this on a local OpenShift. Right. So I'm building a few services that I'm just running locally on my desktop. If you want to deploy this as the next step would be to, I mean, we've got an operator. So, I mean, if you're familiar with OpenShift, you know what it is, but basically we can hand over our processes basically to the operator, and we can say like, well, this is a new one, deploy it. Obviously, typically you have a pipeline that goes through staging and testing, etc. But so the easiest way is basically just hand over this project that I created, hand it over to the operator. The operator has either you hand over a pre-built image, or you just hand over the source code, it builds it, and it makes it available in OpenShift, and then you have it running there. And this is, I mean, it depends on which features it's using. If it uses like timers, it's going to hook it up to a global timer service, or if you have audit, it's going to hook it up to the audit service that the operator can have running as well. So there's quite some complexity. I just focused on the local part because, I mean, that's the fun to see. I mean, I feel like basically the experience should be something like, well, you click it, typically it goes through a pipeline, or I mean, the operator can do it for you, and it ends up, after a few minutes, it really just ends up being live in production. So we focused on a local dev experience, and then when you're ready, you commit to GitHub, to Git, or I mean, whatever, and I mean, there's a pipeline that deploys these things in staging and production. That's what we typically would see as the environment.
All right, thanks. And we're right at 12 o'clock. So Kris, thank you very much.
Thank you. Bye.